Hello Math 1100 students, let's begin Lesson 4. Lesson 4 is a continuation from Lesson 3b. We continue studying graphs, but this time we're going to focus upon much simpler graphs than before, lines and circles only. The line part is going to be a review to everybody, so I'm going to go over those very quickly. As for the circle part, well, that too is a review to most people, or at least a lot of people, but maybe not for everybody, so I'm going to go over those in normal speed. Okay, here we go. Lines, and here's a general form. Ax plus by plus c is equal to 0, or equivalently, after flipping this plus c to the other side, we can write it like this. Ax plus by equal to some number. In this program, a, b, and c values are randomized, so each time I run, you get a bit different line. Okay, so much for the general form. The most important concept in line part is, of course, the slope. Geometrically, it can be written like this: rise over run. The rise is the vertical distance, the difference of y-coordinate, and run is the horizontal distance, the difference of x-coordinate. Analytically, it can be written as delta x over delta y, where delta represents the difference. This triangular symbol is actually a Greek letter. The Greek letter delta represents the difference. So delta x is the difference of x-coordinate, and delta y is the difference of y-coordinate. So what do we have here? Delta y over delta x, the difference of y-coordinate, y2 minus y1, over difference of x-coordinate, x2 minus x1. And that represents the slope. The same thing, rise over run. Remember this delta symbols for calculus later on. Okay, the next topic is slope-intercept form of a line. And here, m is the slope and b is the y-intercept. In this visualization here, b is about negative 1.98337, so pretty close to negative 2. So as you can see, the line is running through a black point, which is pretty close to 0, negative 2. That's y-intercept. And m value is the slope, 2.86 approximately. So as I move 1 unit to the right, I have to go up by about 2.85944. Let's run it again. No, I don't like it. I don't like this one either. Okay, this one's a little bit better. B value is pretty close to 0, so this black point is very close to the origin. And then slope is negative, so m value is negative. So as I move 1 unit to the right, I have to go down by 2.74 units. That's the slope-intercept form. Next, slope-point form. The slope is m, the same concept as before, and the line runs through the point x0, y0. And you can write it like this in the second form, and that form is preferred by our textbook author. Y minus y0 is m times x minus x0. But technology usually prefers this way because usually computers want y equals to something explicitly rather than implicitly like this, y minus y0 equals to something. So if I flip this y0 over to the other side, then I'm going to get this form. And of course, they are equivalent. Personally, I prefer the first expression a little bit more. Both of them are correct, and they are equivalent. Next, 2-point form. We have a pair of points, P1 and P2, with coordinate x1, y1 and x2, y2. And the line runs through these 2 points can be written like this, either the first form or the second form. The difference, of course, is flipping this y1 to the other side. Otherwise, identical. The slope here is delta y over delta x, or y2 minus y1 over x2 minus x1, right here. And the line is running through the point x1, y1. So we have the slope according to the slope formula and the point x1, y1, so you can apply the slope point formula for that. But in any case, we got through this 2-point form. The final topic before some example problems: horizontal and vertical lines. Horizontal lines do have slope. The slope is 0. So whenever you have y equals to b, you can rewrite it in the slope-intercept form like this: 0x plus b. Slope is 0. You see, 0x part, that's 0, so throw that part away, then we have just y equals to b. So we have horizontal line. The slope is 0. We do have slope-intercept equation here. On the other hand, vertical lines do not have slope. Undefined slope. We have x equals to a, as you can see down there. And this one cannot be written as the slope-intercept equation. Y equals to mx plus b. That's impossible because there's no y. Previously here, that's possible. Y equals to b. We have 0x inserted, and then everything is okay. So horizontal lines have 0 slope. Vertical lines have undefined slope. No slope. Okay, so much for all theory parts, and let's go to some example problems, again, very quickly. First problem, find the slope-intercept equation, and that's really easy. All I have to do is solve for y. And here we go. Flip this 2x to the other side, and then divide by 4, and there you go. Any question here? Okay. From general form to the slope-intercept form. Okay, no problem there. Next, this is not the general form. It's a heck of a lot more complicated, but still, we can find the slope-intercept form. I know this is a line because we only have the first degree. X to the first power, y to the first power, nothing more. Now, how do you get the slope-intercept form? I'll have to solve this equation with respect to y. Now, how do you solve it? How do you solve a linear equation? Remember the process? Denominators, parentheses, like terms. Please remember this process. Number 1, denominators. Number 2, parentheses. Number 3, like terms. Do you see any denominators here? Nothing? So we start from the parentheses. Break up the parentheses and then take the like terms together. And then you can do pretty much the same thing as we did before. How do you break up the parentheses? By distributing this -4. And how do you break up the second parenthesis? By distributing this -3 around. Stop the playback and do it on your own, and then come back. Ready? Okay, here we go. Here's the answer key. The original. After breaking up, please note the sign changes. I am distributing -4, including the sign, not just 4. So I have negative times positive, sign change, -8. The same here, I'm distributing -3, not just 3, -3. So we have the sign change here and then there. Remember, there is no such thing as subtraction. We only have addition and multiplication. There is no such thing as subtraction or division. They're just inverse procedures, just adding negative numbers. So the sign is part of the next number. Okay. From here, taking the like terms together, and then solving for y, tedious but elementary. How about the next problem? This one, I'm going to leave the details to the students. Remember the same thing. Denominators, parentheses, and like terms. Here, you'll have to start from the denominator. If you do it right, you're going to get this line, but the detail is left to the students. Okay, some more example problems. Okay, find the slope-intercept equation of the line that runs through the given pair of points, and we have these two pair of points, these 2 points, 2, -1 and -4, 3. My first reaction here would be using this 2-point form. Plug in these numbers to x1, y1 and x2, y2. Simplify, and then you're going to get the answer. Either you use the first form or the second form, it doesn't matter. Either way, it's correct. All right. Have you done it? Not yet? Then stop the playback and do it. All done? Okay, I'll show you the answer key here. There. Plug in those and then simplify. Plug in 2, -1 and 4, -4, 3 in right places, and then simplify those numbers, break up the parentheses, and then take the like terms. You get the slope-point equation. Excuse me, slope-intercept equation. That's a direct solution, and I like this method the best, using the 2-point form. But that's not what our textbook author does. This is the textbook solution. So here is a slope-intercept equation. That's what you want, and you have to find out the m value and b value. M we can find out from the slope formula, y2 minus y1 over x2 minus x1. Plug in the numbers and do your computation, and there you go, -2/3. So that's something I'm going to plug in here in place of m. And then as for x value, I can plug in either 2, -1 or -4, 3. I just decided to put the first point in. And there, m is -2/3, x is 2, y is -1, and then solve for b. Plug in those numbers, and this is an equation of b. Solve it, and that's what we get. Therefore, we have this answer. Now, do you prefer this multi-step process? If you do, you can go ahead. Otherwise, you can go through the single-step process. Me personally, I use solution 1. And the hybrid solution using slope-point equation, I'll just skip that. I think I made my point. All right. The final problem here, the slope-intercept equation of the line that has slope -1/3 and runs through the midpoint of the following pair of points. So we have the slope m, so -1/3, and then you can find out b value by appropriate equation, which is possible, but I don't recommend it. Or you can use slope-point equation and find out x0 and y0. How do you find x0, y0? It's a midpoint of those two, so you can find out the midpoint using the midpoint formula. Remember? That's a midpoint. So plug in all those values in. Slope, -1/3, and the point is -1, 1. So put it into the slope-point equation and simplify. There you go. Okay, I'm not going to bother talking about the textbook solution using the equation and looking for b value. So much for the review on section 1, and let's meet again in section 2.